Let's say we are given the equation x is equal to 6t squared minus t cubed, and x is the position of our particle. And we're interested in finding its velocity, and we're interested in finding its acceleration. So if we look at what its velocity is, we know its velocity is equal to the derivative of its position with respect to time. So we know what its position is. We know its position is 6t squared minus t cubed. And we know the denominator is it's dt, so it's the derivative of x with respect to time. And if we perform this derivative, we get 12. The velocity is equal to 12t, 12t minus 3t squared. Now, to get the acceleration, we know acceleration is equal to the derivative of the velocity with respect to time. So let's clean this up a little bit. And we just found a expression for velocity. So we know the acceleration is equal to the derivative of this velocity, which is 12t minus 3t squared, with respect to time. Now, if we perform this differentiation, we get that the acceleration is equal to 12 minus 6t. And now we have expressions for our position. We have expressions for our velocity. And we have expression for our acceleration. And what I have done is I've gone ahead and I've graphed them in this graph over here. So this top graph is this function plotted out. This middle graph is our velocity function plotted out. And this third graph is our acceleration function plotted out. Now let's go ahead and just show where these lines are zero. So this is where this is zero. This is where this one is zero. And let's look at some key features of these charts. So let's start by looking at t is equal to 0. And when t is equal to 0, we have x, which is 0. That's not a very good color. This is better. We have x, which is 0. So x is equal to 0. Our velocity is equal to 0. And we have an acceleration that is positive, and it's actually positive 12. But what's important with our acceleration is not the slope of the line. It's not the slope that shows you our acceleration is sloping down. It's the actual magnitude at the of the acceleration at this point. So our acceleration is positive at this point. And it's actually positive 12 meters per second squared. But let's keep looking at what happens. And if we look at our next time interval, the next big thing that happens is when our time is equal to 2 seconds. So when our time is equal to 2 seconds, right here, we notice that our acceleration is crossing 0. So our acceleration is equal to 0. And what is our velocity? Well, our velocity is actually at a maximum point. So when our acceleration is equal to 0, our velocity is equal to its max. And that's, in general, a max velocity occurs when its derivative, and in this case its derivative is dv dt, is equal to 0, and that's what we see right here. So let's keep looking at this, and let's look when our position is at a maximum. Well, well, before we do that, what's happening at time equals 2? Our position, our x, is still increasing. It's still a positive position. So let's look at what happens when our position becomes a max. And our position becomes a max when our time is equal to 4. And we can see that right here. When time is equal to 4, our velocity crosses 0. So our velocity is the derivative of the position with respect to time. So our max position, our displacement, occurs when its velocity, when its derivative, so when the dx dt is equal to 0. And we see that right here. When the velocity crosses 0, our displacement is at a maximum. So at time is equal to 4, x is at a max, velocity is equal to 0, and our acceleration is equal to some negative number. And finally, at t equals 6, at 6t, so time is equal to 6, our x position becomes 0. Our velocity, well, it's continuing to become more and more negative, so it's some negative number. And our acceleration is also a negative number, and it continues to get more and more negative. So this is what happens at time is equal to 6, time is equal to 10, time is equal to, well, that's not true. At time is equal, when the time is greater than 6 seconds, our position is now a negative number because it's trending down like this. Our velocity continues to come down like this, and our acceleration continues to go down. So when a time is greater than 6 seconds, x is equal to a negative number, our velocity is equal to a negative number, and our acceleration is equal to some negative number.